Hello and welcome to the TES Secondary Maths Resource of the Week number 107 with me, Craig Barton. Now, I'm going to confess from the outset I'm dead excited about this resource because I flipping love a puzzle. And the puzzles that I like the most are those that are the simplest to explain but have a level of challenge that just keeps getting bigger and bigger and bigger. Because if they're simple to explain and also easy to access, that means students straight away are engaged in them. But of course, if they're hard to conquer, hard to master, then you've just got so much mileage you can use them for. And what's particularly nice about this is the concept is so simple, but I can just see so much potential for extension and probing questions and so on. Now, after that build up, this may be the biggest anticlimax ever, but hopefully not. So the resource is called Grid Sums Puzzle, and it's been uploaded by one of my favourite resource uploaders. And it's the most simple looking thing you've ever seen in your life. It's just a single Word document. So if we just crack it open down here, you'll see it looks like this. And this is a grid sum puzzle. Well, this is one iteration of it anyway. So start off with a blank 3x3 grid. So straight away I'm interested there because there's no messing with printing off fancy worksheets or anything like that. And then as we see here, there's already a hint of some of the extensions that could come into play. And then here are the rules. Now, like anything, it's going to take a little bit of explaining, one run through, perhaps playing it as a whole class, but then the kids will be up and running. So here's the instructions. You choose empty grid cells one by one. Each time you choose a cell, you add up its neighbours and write the total in the cell you choose. If all its neighbours are empty, you write 1. Keep going until your grid is full. Make the last number as large as possible. Easiest way to explain this is to look at some of these wonderful instructions. So imagine we're playing a little two-player game. Or one-player game, for example. I'll put a 1 in the top left-hand corner, and because there's nothing else around it, I'm just going to leave it as a 1 there, and I'll also put a 1 in the bottom right-hand corner, nothing else around it. So then you think, right, I'm going to choose this middle square here. Now its neighbours, there's got a 1 up the top and a 1 down there, so its neighbours add up to 2, so you put a 2 in the middle square. Then I'm going to choose this square here. I've got a 2 down there and a 1 touching it there, so its neighbours add up to 3, and so on. And you keep going until you've filled the square. And the idea is that the final number you should put in should be as big as it possibly can be. And in this example, it's 36, but here's your little twist there. That's not a bad score, but it's possible to do better. So the obvious question is, what's the largest final total that you can put in there in a valid grid square? So there's your first bit of investigation, and you get some lovely little blank squares there to play with. But as I say, you can play these just in the squares in students' books. Then look at that, a 5x5er. Or you could have a 4x4er or a 6x6er or whatever. Absolutely ideal. Some hexagonal grids come into play here. Absolutely brilliant stuff. Look at that flipping massive hexagonal grid. And I'll just scroll to the bottom, then I'm just going to talk about how I've used that. Again, another extreme one there. Now, what I like about simple resources like this is there is so much potential for extension. So one option that sprang to mind immediately is you could play this as a bit of a competitive two-player game. So firstly, you could do yourself working together to get as big a score as possible, and then maybe working with somebody to get as big a score as possible and discussing your tactics. Absolutely fine, absolutely ideal. Then what about a two-player game where every time you pick a square and write its total down, you get that number of points, and then it's the next person's go and they get that number of points. So your goal that time is both to maximise your number of points, but also not to set your opponent up to try and so they can't get as big a score as you can. So you get a bit of competitiveness in there. But then there's loads of potential. What about if you allow negative numbers? What happens if you allow fractions in there? Can you prove what the biggest number must be? What about getting the smallest number possible? What happens if you're only allowed to put even numbers in there? What happens if you have to put consecutive odd numbers and even numbers? Just loads of potential. And those of you who've been following my work, well, kind of for the last few years really, when I've got a bit obsessed with rich tasks and specifically differentiation through probing questions, will know that this is right up my street. And indeed, whenever I get a bit of time, I'm going to create a rich task around this that's just going to start off with as simple way as possible, but then I'm going to try and think of 10, 15, 20 different lines of inquiry and probing questions that students can use with this. So please, to kind of help me along with this, get your thinking caps on, and if you think of any probing questions, twists, extensions or whatever, put them in the comments and then I'll build them and compile them all together. But try this, because I think with the simplicity of it, and sorry I should have said this at the start, the only math skill students need to be able to access this is to be able to add together numbers. So it's great practice of kind of mental arithmetic like that. But Of course, with the potential to bring improved generalization, hypothesis, creativity, representation, all that, then you've got a resource that can be used from anything from a low attaining year 7 right up to year 11, your year 12s. I'm not even ruled out chucking this in with my year 13 further maths. So I love these grid sum puzzles. I think this has got potential to be a bit of a go at this one. So if you can be having a think of ways that you would extend it or different directions you take it, pop them in the comments, and then I'll build a rich task around this whenever I get a bit of spare time. Okay, I hope that was useful. I shall return with a fresh resource of the week next week. Take care and farewell for now.